Shegufta, and I'll be talking about electrifying materials processing. Heat equals change for a lot of materials processing techniques. And typically this heat is generated indirectly, which means you have an outside heat source from where the heat is transferred to the heating chamber first, and then from there to your sample through processes like conduction, convection of air currents, and radiation. As you can imagine, there are a lot of energy transfer losses. In fact, 1/3 of the energy is lost as waste heat. Surely there must be a better way we can heat our materials, right? In our group, we believe that the best way to do this is to generate heat directly within the material. How do you do this? For me, I study metal oxides, and I grow the metal oxides onto a network of very conductive material called carbon nanotubes. And you can imagine the structure like a spider web. So the idea is to pass electric current into this network so that the carbon nanotubes heat up, and in the process, the surrounding metal oxide gets crystallized. In other words, you're generating heat directly within the material from the inside out. This process is very fast in terms of seconds or even an instant versus hours using indirect heating. There are almost no energy losses, so it's very efficient. And it is as simple as tuning the input power to get different target temperatures to get different crystalline phases. And as a bonus, you can get crystalline phases that are far from equilibrium. For example, the 1T metallic MOS2 phase, which is impossible to get using indirect heating, at least as a bulk material due to heat transfer limitations. Also, due to the limited time, you get smaller crystallite sizes, which means larger surface area. And this is ideal for applications like catalysis and charge transfer in battery electrodes. So what does all this mean? Our simple processing technique can be used for similar composites with a conductive network to save time, energy, and to get unique crystal structures. All you need to do is provide electricity, and what you end up with is the final heat-treated material. The decarbonization future is to electrify, and I believe that includes materials processing.